Today we are going to learn about equal vectors and parallel vectors. When two vectors A and B are equal, we can annotate it by this manner. So, what does it mean when two vectors are equal? Say, vector A is equals to 2, 1, and let vector B be equals to 2, 1 as well. And we realize that vector A equals to vector B. Now using a directed line segment, let vector A start from this point. It will move 2 units to the right and 1 unit up. So a vector A will look like this in the form of a directed line segment. For vector B, since it has column vector 2, 1, it will look like this. And you realize that when two vectors are equal, the vectors are also parallel. And when vector A is exactly equals to vector B, these two vectors have the same magnitude. And we can write vector A is equals to 1 times vector B. In general, when vector A is equals to k times of vector B, how will it look like? Now, let vector A be equals to 2, 4, and let vector B now be equals to 1, 2. And we will draw a directed line segment starting from this point, 2, 4, and this directed line segment will represent vector A. For vector B, starting at this point, we will have 1 unit to the right and 2 units up, and vector B will be represented by these directed line segments. And now you realize that vector A is actually twice the length of vector B. So when vector A is equals to 2 times of vector B, the vectors must be parallel, and the vector A is 2 times the magnitude of vector B. And we can verify this by looking at the magnitude of vector A is actually equals to square root of 2 square plus 4 square using Pythagoras theorem. And the square root of 2 square plus 4 square will give us 4.47 units corrected to 3 significant figures. The magnitude of vector B is equals to square root of 1 square plus 2 square, and it is equals to 2.24 units rounded off to 3 significant figures. And you realize that the magnitude of vector A will be twice the magnitude of vector B. Finally, in general, when a vector A is equals to k times of vector B, these two vectors must be parallel, and this vector A will be k times the magnitude of vector B. Say we now have a question saying that vector P is parallel to vector Q, and vector P is given by the column vector 8, negative 10, whereas vector Q is given by the column vector 8, 15. How do we then find the value of n? since we know that these two vectors are parallel, we can let vector P be equals to k times of vector Q. Writing it in terms of column vectors, 8, negative 10 will be equals to k times of n 15. And in order to find n, let us first find the value of k. Negative 10 will be equals to 15k, and k equals to negative 2 over 3. And now we can find the value of n by substituting in the value of k that we have just found. And solving for n, we realize that n is equals to negative 12. And yes, you may ask, if these two vectors are parallel, then can we use the gradients to find the value of n? So vector v equals to xy represents a vector of x units in the positive x-axis direction and y units in the positive y direction. So if x is positive and y is positive, our vector v will look like this. And to find the gradients of vector v, we can let it be equals to rise over run and equals to y over x. Applying it to the previous example where p equals to 8, negative 10 and q equals to n 15, if these two vectors are parallel, then the value of y over x should be equals to the value of y over x for vector q. And indeed, solving it, we will have n equals to negative 12, which is the same as our previous answer. To summarize, when two vectors a and b are parallel, we will annotate it in the form of vector a is equals to k times of vector b. When a equals to k times of vector b, the two vectors will be in the same direction and hence they are parallel, and they will differ by the k times the magnitude of each other.